Okay, welcome back. So, more experimentation. So, the last couple of weeks, I've been doing some live coding in front of you, and I hope you got an appreciation of test-driven development, sort of this mindset that you get in to think about what your code needs to do first, write a test that you think does it, watch it fail, implement it so that it passes, see it pass, and then refactor, make your code better, clean it up. And I'd like, I've been doing some live coding, and I'd like you guys to spend some class time thinking about code and maybe writing some code together. So we're going to try something this week. First, I've got some introductory videos that I want you to watch talking about something called a code kata, and there's our coding dojo, and then a video on pair programming. And then what we're going to do is we're going to introduce a coding kata, what I think should be very simple, coding kata. And I'd like you guys to break up in pairs. Okay, and there's even much use. No one gets a pair with me. And we're going to spend a couple of minutes thinking about the problem. We'll come back. We'll talk about the problem a little bit. And then I think there's enough of you with laptops so that you can pair up and then do some coding with each other. And then we'll reconvene and talk about what we did and what we learned. So, experimentation. Okay, so first let's start off with a
So what is a coding dojo? Well, first off, the most important part is really the setting. So if you imagine the setting to, of course, of a single computer, it's attached to some kind of projector, and of course that projector is projecting up on the wall here. And then the other important part is to have a secondary space, usually a whiteboard or a flip chart, where the problem and ideas can be written up there. Along those lines, of course, you've got two pair programmers or spars who are working together, a pilot and a co-pilot, and then you have the dojo participants who are sitting around, usually no more than, I'd say, 12 to 15 people. Okay, so that's the setting. Now let's go on to the people, the roles, and it's important to note that all of these roles have to actually have someone in place at all times and acting as responsible for the job of that role. So, role number one is the sensei. As you can see here, there's no sensei listed, and that's because usually the sensei is somewhere off in the distance in the background, watching and guiding the dojo, not giving instructions or solutions, but rather pathways to the solution. Remember, there is no spoon. Okay, number two, pair programmers. These two people are the spars. One of them is the pilot, so one of them is typing, and it's their job to write down the syntax and start to throw out ideas in a way to be on the offensive, to be the attacker, and to get the ideas up on the board so that the rest of the people can overlook at it and provide other solutions. The other person, the co-pilot, the fellow pair programmer or spar, their job is to look over the other code that's being written by the first spar and to kind of be on the defensive, to try to help and suggest ideas and to kind of quietly whisper in the ear and help the first person. It's very much the idea that these two people are working together. They're not fighting. They're training one another to be able to do the best job in the same way that a kata would be performed in karate. Finally, other than your two pair programmers in the middle, are kind of the advisors. Now, it's really important to notice that all of these people that are around the room, they're all participating at the same time. Oftentimes, they'll hop up and they'll write on the problem board themselves. They'll shout out answers if they see something done differently by the primary pilot programmer. And then the other important thing to notice here is that everyone has to take an opportunity, a chance to be a pilot and a co-pilot. So you'll very much have people switch out and to take their opportunities. Usually about 15 to 20 minutes, someone will sit in the pilot and co-pilot seat and then switch out. So usually you'll take your first go as the pilot because you'll need to learn how to type the syntax. And then once you're kind of getting the idea of how to type the syntax of the code, you'll have the second co-pilot who can then swap over and help advise the new person coming in. So everyone in the entire programming dojo must participate. which brings us to the rules, actually. So let's go on to the rules of the coding. So now let's go to the rules of the dojo. So one of the most important parts is, number one, the sensei asks questions, does not give answers. And so the real point about the sensei, who's obviously kind of somewhere in the background to this activity, is just providing guidance. There is no spoon. They're just teaching you how to move forward. Often the problem that they give, or the challenge they give, is given beforehand, usually a week in advance by email, so people have time to think about it. All right, rule number 2. All must participate in code being written. And what it means by that is that all of these participants around the edge who need to take their turn in the middle at some point, all of these people need to be watching the primary coding board. So what's going on with the two sparring partners and what they're writing. They need to be looking up here and participating, and ideally helping contribute by suggesting solutions. They should not have their own computers out. Not really. They should be, unless they're trying to look up stuff or something else. I mean, there's no strict rules, but ideally they're not coding by themselves. They're trying to team code and help this person learn as much as the rest of them will have help themselves when they code. Finally, rule number 3, everyone must participate in sparring, which means that everyone must take their turn as pilot and co-pilot in both typing and also helping teach how to type. So this person, this person, this person, this person, this person, so forth and so on. Every single person should switch out at some point, come and take their turn to type, and then swap out and take their turn on helping to advise and all the rest of it and give solutions. So that, in essence, is the Coding Dojo. Cheers.
So I don't know if we're going to get to all of that tonight.
So what do you want to accomplish? Like everyone is doing the same code thing or the same?
For tonight, I don't think we're going to get to that full dojo because, well, both time and also I think the problem's really quite simple. I think tonight I'd like you to focus on is doing some pair programming, but think about that dojo concept. I'm going to think some more on it too, because it's something I like to experiment maybe in the coming weeks.
Why?
Why? So that, well, I mean, I hope you saw the benefit of you watching me code, but that was me coding by myself, and I suppose I was sort of talking to you during it. But as we'll see, now when we talk about pair programming, having that conversation going on between two people generates better ideas, and it helps. Well, it results in better code, and it's something that I want to have you guys experiment with, and and tell me what you think about it. So I hope you go into this with a spirit of inquiry of something that may or may not work for you. I don't know, but have any of you been in a coding dojo before? Have any of you done pair programming before?
Pair programming is okay, it makes sense, but in Dojo it seems like only 2 people or maybe 1.5 people are being productive, and remaining everyone is just being audience.
The dojo is a learning exercise. So yeah, I mean, this isn't like swarm programming. And maybe I should have been more clear. The intent of the dojo is a learning exercise, and it's the same way in martial arts. There are 2 people who spar, and then everyone else is observing, and so they are participating, and they are observing, they are learning. Right. So it's not about.
It's not professional development in an organization. It is about a classroom.
Right. So yeah, and so I should be more clear about that up front. The dojo is more appropriate for a classroom environment, something I like to experiment with here. But pair programming is is effective for both. Dan? Yeah.
So does this kind of go parallel with, like, you ever heard of mob programming?
Yeah.
Yeah. So I've done it at work, and it's pretty awesome, and it's not really primarily a learning tool. It was more of like, everybody get on the same page of the major hurdles that that you're going to face in the next week or 2. It wasn't like a planning meeting, but it was like, let's dive into the code.
Right.
Yeah.
Yeah. Let's think about that, because it might be that we do a couple of dojos, and then if we're feeling comfortable, or if it's like a good juicy problem that we can all dive into. Doing mob programming. So I think so I agree. Mob programming is the non-classroom equivalent of getting everybody into an environment like this. Lots of people, all one room in front of one projector. I assume you do that. One IDE, one projector, everybody contributing. Okay. And here's a video. It's kind of cheesy in places, but it's really sort of the best. Did I say TED Talk with Sarah Silverman? Oh, TED. Oh, okay. Sorry, it was not a TED Talk with Sarah Silverman, because that would be awesome. Okay, sorry. Here is a video about pair programming.
Hello and welcome to Fun with Pair Programming, an introduction to pair programming for students. If you're a student who is new to pair programming, you've come to the right place. This video will help provide valuable information to make you the best pair programmer you can possibly be in your classes and beyond. Pair programming refers to the practice whereby two programmers work side by side on one computer, collaborating on the same design, algorithm, code, or test. The pair is made up of a driver, who actively types at the computer or records a design, and a navigator, who watches the work of the driver and identifies problems, asks clarifying questions, and makes suggestions. Switch roles from time to time to share the work evenly and get the most out of your pair programming experience. You'll hear effective pairs constantly chatting as they jointly decide how to tackle the task at hand.
Well, actually, I don't even know where it's saving this stuff. So we create a new patient and it adds a record. Oh,
All right.
probably in save data file. Mm-hmm. So it's going through, looks like a list of records.
Mm-hmm. So we probably, since we just added the height and weight, I don't know if that's actually getting written.
Yeah, probably not.
Okay.
So
Why do so many thousands of students around the world prefer pair programming? Why don't we ask some to compare old-fashioned solo programming to this new and innovative system?
Wait, what was the order?
You would program by yourself, so you'd usually be just by yourself in a computer, maybe in a cube or at a single desk, and it's a very lonely type thing. It can be.
Well, it could be really frustrating. You'd sit there banging your head against a desk and trying to find, the missing bracket, or couldn't figure out why the logic in your program didn't quite work right. And with two people there, it's a lot easier to work those problems out a lot more quickly, so you're not frustrated all the time.
This is nothing new either. Most science labs take advantage of lab partners and small groups. Computer science is no different. You can learn a lot from working with other people. Students find it helps them get better scores on programming projects. Pair programming helps them learn, so they get better grades on exams as well. Mostly, students report that they enjoy getting to know the people in their classes better. This makes it much easier to interact when problems do arise, because you've got a class full of friends instead of strangers. Last, but certainly not least, students are much more likely to figure out solutions if they've got someone to brainstorm with, and this can lead to faster completion times and a better understanding of the subject matter. Students often find the whole experience much more enjoyable and less frustrating. Pair programming will also help you prepare for your career in computer science. In the professional world, people collaborate and pair program all the time, and as an expert, you'll already be ahead of the game. Have you ever spent most of your class time with your hand in the air, getting nowhere on a project while you wait for help from your professor or lab instructor? With pair programming, those days are history, and you'll find yourself having a lot more fun. Who knows? Maybe you'll even look forward to the alarm going off in the morning so you can get to class. Now that you know the basics, let's look at some simple do's and don'ts of pair programming. First, be sure to talk. Not a minute should go by when you're not communicating somehow. Don't say anything that might insult your partner. Even if you're only joking, he or she might take it personally. Don't forget to listen too. Both the driver and the navigator should be fully engaged in the project. So much so that the driver can pass the keyboard to the navigator at any time, and he or she will be ready for the switch with no questions asked.
Periodically switch positions so you can gain experience in both roles.
Switching helps prevent errors and stimulates conversation too. Be patient. Be prepared to explain yourself to your partner, and don't get frustrated if they don't understand it first. By explaining your work to your partner, you'll be helping yourself learn as well. Remember the ancient Chinese proverb, to teach is to learn. And be sure to give the driver a little time to correct his or her own mistakes. After all, no one likes a backseat driver. Respect your partner. The golden rule is key here. Just remember to treat your partner with the same level of respect that you expect from him or her. It doesn't matter if they are from another culture, an introvert, an extrovert, a procrastinator, or the valedictorian. We are all here to accomplish one thing, and everyone has something to offer. Take breaks. You can get more done in 1 hour pair programming than in several hours by yourself. But this can take a toll on your brain. Don't forget to take a break every so often to keep yourself fresh and energetic. When you return, you'll likely see something you overlooked before. Be prepared. Be sure to do any preliminary work ahead of time, and don't be late for appointments with your partner. Their time is valuable, as is yours. Hygiene. Think about it. How would you feel if the person you were going to spend a couple of hours with smelled terrible? Take a shower, brush your teeth, bring some mints. You know the drill. Have fun! Working with someone else can be a lot more fun than working by yourself. You can share a laugh, relieve some tension, and have someone to celebrate with when you get that last test case to pass. Believe me, that's a great feeling. Now that we've gone through all the things you should do as a pair programmer, let's go through some of the things you should avoid when working with your partner. Don't be a keyboard hog, or think that just because your partner is a novice and you're more experienced, that they won't bring something to the table. Don't constantly tell other people what to do either. You don't want to be the only person in the class that no one wants to work with because you're too bossy. There is another side to that coin, so don't be intimidated. Some people are afraid that they don't know enough, but chances are your partner feels the same way, and you both know way more than you give yourself credit for. Trust me, it will all be fine. The primary goal of pairing is to work together towards the best possible solution, so don't be afraid to speak up if you disagree with your partner from time to time. Your partner may as well be working alone if you're not willing to speak up. If you're unhappy with your pair programming situation, for any reason, don't hesitate to talk to your professor or teaching aide. That's their job, and they will be happy to help you resolve whatever problem you may have. As you can see, there are many benefits to pair programming, but there are also a few speed bumps. Sometimes you'll find it difficult to find time in your schedules to meet, for example. But students all over the world agree that the benefits outweigh any drawbacks that they can find.
If there's two of you working on it, typically you're spending a lot less time working on it, so this is great for homework. Then also I would say that in general, your solution is going to be better.
So if you're working with somebody and their grade or their deadline matters to you, you're more likely to get your work done at an earlier time. Also with pair programming, you can typically have higher grades on assignments. There's higher quality code as well.
This concludes our journey through the exciting world of pair programming, but there's still much to learn. Take these tips with you into your next pair programming lab and join the growing number of pair programmers across the country, the world, and beyond.
Wow, that was really cheesy. Okay.
Parts were kind of cheesy. I don't know about that.
I think the message was good. I think it was delivered in like kind of a lame way. But anyway, right on. So here's what I'd like us to experiment with next. So whenever that was over the weekend or something, I posted something to Google Plus about like what we'd be doing tonight. For our first pair programming code kata, I'd like us to attack this FizzBuzz kata. So basically, the whole idea is that pretend you're in math class and you've got some like psychopath math teacher that has everybody going around the room, and to teach you about divisible numbers, you either say the number unless the next number is, unless your number is divisible by 3, and then you say fizz, and if it's divisible by 5, you say buzz, and if it's divisible by both, you say fizz buzz. As you can imagine, this is, and so what you need to do is write a program that basically prints out the numbers 1 to 100, but when you've got a multiple of 3, print fizz, and when you've got a multiple of 5, print buzz, and when you've got something that's divisible by both, print fizz buzz. And so what I'd like you to do is go off and so find a partner up, so make sure that at least one partner has a computer that that they can work on and are willing to share. First, let's think about the problem. It doesn't seem that hard, right? So let's only spend 5 minutes thinking about the problem in pairs. Then we'll come back and get some thoughts in terms of how you're going to attack this, and then we'll break off again and sit down and do it. Okay? Okay, so we've had a couple minutes to think about it. What are your plans of attacks? So, like, how are you going to approach this problem?
So essentially, it will be a class which will have name method where we can have a for loop. The for loop will go from 1 to 100, and for each number will be, and there will be 2 methods as well, fizz and buzz. So for each of those numbers from the for loop, we'll be checking on both of those functions to see if it is really divisible by 3 and if the module would for that. If it is coming to 0, the division, and if it is coming to 0 after dividing by 3 or 5 by either of these 2 functions, we print fizz buzz.
Okay. Other people, what are your ideas for? What are your ideas for how to test it? Anybody talking about how they're going to test it? Should you?
Just run it over.
Like it doesn't need to be, because it's sort of like a determinist, like every time you run the program, the same thing's going to happen.
Okay, no, I think that's fair. Like I meant, yeah, the logic does seem pretty simple. For the sake of for thought experiment, so if you were going to apply test-driven development to this, how would you do that?
I'd probably hand code something like that, a list of known values, and then just compare my output against that.
Yeah, probably works.
Assert that I equals whatever.
Assert that I equals whatever. You mean like
your value equals, and you're testing for a code check, and then you can see if that actually comes up with the proper output.
Okay, right. So you say, okay, for printing. So if tell me if I pass in 3, I should get back fizz. If I pass in 15, I should get fizz buzz. Something like that. Yeah. Yep, sounds good. Okay. So I just posted to Google Plus a Maven command line. Oops, where'd it go? Sorry. Maven command line for creating an archetype for just like a very simple application if you want to use Maven to build it. Otherwise, if you're comfortable doing something else, no problem there. How long do you guys want to spend developing it? When should we reconvene? 20 minutes? Is that enough? 10?
Do you want us to do a test as well? Do a test driven development with this?
If I were doing it, if I was doing it with a pair, I would recommend with that my partner and I do test-driven development. I'd recommend that you do it. I'll leave it up to you, though. And actually, that might be an interesting. Well, I mean, we could also say, hey, some people do test-driven development, some people don't, and compare notes. Okay. Well, so we'll check back in 10 minutes then. See where people are at.
Oh, how do I unshare my screen?
Well, they're going to see us if you're talking. It tracks movement.
Yeah, I can mute that. Yeah, let's mute myself. Okay, so like how? Oh, I guess maybe Scott is. There you go. That's awesome. Okay, recursion. Okay. So you guys. So let's see here. Who's Ben? Is this your screen that I'm looking at?
No.
Okay. Well, how about you guys? Would you guys mind coming up here and talking to the class and tell us basically? I guess I want to hear a couple of things. I want to hear about the process that you followed, and like bring your laptop so you can point to stuff that is happening. Sit down and tell us what your experience was like.
So we did two. Like the first one's commented out because the second one's a one-liner. The first one was pretty straightforward. Just the string output is what we're going to end up printing out. So output starts as a blank string, and then if I mod 3 equals 0, then we append fizz. Then if I mod 5 is 0, we append buzz. And then at the end, we just, if output's still an empty string, then we make output I. Otherwise, it's going to be fizz or fizz buzz or buzz, I guess, either one. Then we just print it. And then the one-liner is just that logic using ternary operators into one line.
Yeah, I'm trying to make it bigger. Is that a little better? Can you control plus that?
Zoom in. Here we go.
Whoa.
I don't know how helpful that is, though. Let's zoom it back out.
Okay.
Yeah, so that
the initial 9 lines there are the fizz buzz all together, and then he just quickly put together into one line and commented out the original.
So yeah, it's the same thing, just with ternary operators because they're fun.
Cool. So, which version of the program do you guys prefer?
Well, like if I were gonna like release this code, it would definitely be the first because it's readable, and this one's not. But you know, it's like a novelty. It's fun to do.
Cool. You did have 15 minutes, so okay. What was pair programming like for you guys?
Well, I always like it. It's more fun just to talk to people. And
We were actually, I was actually able to ask questions because I have some difficulties with the Turner outputs and then also figuring out, where the different parts of the coding go. So it was very helpful.
How did you know that your program worked?
We just ran it and hoped
Didn't
for the best.
crash.
Didn't crash? Yeah, right.
It looked right, so that was good to have.
Awesome. You guys have any questions for these dudes?
I don't get it. So what we're doing with, we're trying to append a string fizz into output.
Yeah, so at the start, just the string is empty, right? And then if I'm on 3 equals 0, which is the case where it's a multiple of 3, then we're going to make output equal to fizz. So at that point, if, say, I is 3, then it's just going to be fizz. Then at the next point, we're going to do I equals, if I mod 5 equals 0. So in that case, it would append buzz, but only in that case where it's either a 5 or it's a 3 and a 5. So then it would be fizz buzz if it's a 3 and a 5.
And you put a false together into a tertiary operator.
Yeah.
I didn't realize you could do all that logic using system out print line. Like, can you put like if statements and like?
It has to be. What is it? It can't be like a statement. It has to be. Like, there's a term for it, but I don't know what it is. But basically, an expression. I think it is. It has to be an expression, and the ternary operator is considered an expression, so it works.
Cool. Awesome. Any other questions for these guys? No, thank you. Anybody else want to talk about their solution? Who would like to go next? So those guys didn't do any tests. Did anybody take a test-driven development approach? You guys did?
We just need to wrap one little part of it up to be sure.
Okay.
We
So,
didn't quite get the main loop down, but give me like 5 seconds and I'll have it done.
The testing was actually done wrong.
oh, I see. I want to hear about that. So anybody else want to talk while they're quick finishing up?
Yes, we could.
Yeah. Why don't you guys come up? So let's see here.
So screen share.
Share that screen before everybody gets sick looking at you.
Oh. It's like crazy episode of The West Wing ever.
My first time. Okay, so
Vibration has been detected.
yeah, Tasha bar thing. I don't know if everyone can see that, but we just have a for loop, and we checked if they're both, if I mod 3 equals 0 and mod 5 equals 0. And so print fizz buzz, else if I mod 3 equals 0, fizz, else if I mod 5 equals 0, buzz, else just print the number.
Pretty simple, pretty easy.
Anything to add to that?
Really.
Cool. Compare the solution with the previous one? What do you think? Are pros, cons? Or?
This seems simple to read. That one is just in one line, but the tertiary operator used the nested loop. Within the tertiary operator, that kind of is complex to understand at a first glance.
What do other people think?
Well, I mean, I kind of agree. I mean, tertiary operators are kind of hard to read. I mean, if you just put one of them, it's fine, but two of them is like more difficult. This was, straight up, but I like using tertiary operators as well.
It is very tacky. I mean, it's efficient in one line and everything, but kind of hard to understand.
Okay.
And in this, I'm noticing that we don't necessarily need to have that first and condition. We could run those one after another as part of if.
Oh, good point. Can you talk to that a little bit more?
So, say for example, in the first condition we just run if I mod 3 equal to 0, then print fizz. And then rather than else, we just go into the Nexus step. If I mod 5 equal to 0, then print buzz. So that will go together.
No, I don't think that would work actually.
That work.
But the problem I was thinking of is that if, say, so you're saying if on this and then if on this, else. But it would be the if else would print both the I mod 3 and the number if it was mod 3 was true. But
So in the first condition, you only check for 3.
Yeah.
In the second condition, and they are all unrelated. They are not if else. It is all if. In the second, you check for 5, and in the third one, you check it is not equal to not 3 and not 5.
I see.
So there are 3 needed, not 4 in that case.
I see. I understand what you're saying.
Cool. Anything else in this one? No? Awesome. Thank you very much. Who's next?
Well,
Ben? Come up. You guys want to go?
yeah. So I think I have screen share working. Is that?
That's looking pretty good.
Sweet.
What was it?
I just exited it out and did it again.
Oh, okay.
Oldest trick in the book.
That's what I just do. Oh wait, I didn't just leave, did I? Oh, here we go. I just do.
Test cases first because
Oh,
there's only things different.
Okay, so you guys took a test-driven DDD approach to this. So how did you start out?
Yeah, so the reason why we did that is because it seemed like it was fairly easy. So so we went with this to kind of learn a little bit more about the test-driven development. And so we broke it down into 3 test cases, and so we had 3 different methods. And we had is divisible by 3, is divisible by 5, and is divisible by 3 and 5 were our tests. And,
So yeah, so we did 3 methods, which obviously is not necessary for this since they're all pretty quick methods. So here, well, I'll show you how awesome our tests are. If you run them all tests passed. So we just did each of the tests first, and then we went in here. We've got 3 static methods for is div 3, is div 5, and is div 5 and 3, which is again just for to make it cleaner. Here's our code. And that's it.
Yeah, so we started off just like it explains like how you want it to fail first, and then we went in and implemented these.
Well, that's
Boom. Oh, looks like it's not picking up that last. That's weird because it's still showing like the unit test running over here.
Oh. Well, it works. Trust us.
Oh.
Let someone else know.
Oh, this. Am I looking at the wrong one?
Yeah. Right. No, that's you. Over here. That one?
Yeah, no.
I think
like
it's this one over
my
here.
head, so I guess I stopped doing.
Oh,
screen
so
share.
yeah, it's up to a screen share somehow. It's weird.
Yeah.
Okay.
All right. So there it is.
Okay.
It was kind of cool because
Yeah, it was cool.
I
to
haven't been
test
testing.
development.
I haven't been writing my code like that.
So can you go back to your tests again? Cool.
Yeah, so it's really easy. Like, neither of us have done test-driven development yet with any of these projects, even though it seems really great. And even with a project that's easy, it was, obviously not necessary, but it was kind of fun. So
Yeah, it gives me the impression it's pretty methodical.
So what do you think? Oh, I'm not done with you guys yet. What do you think about these tests? Is there another approach that they could have taken to testing?
Well, so we thought what we could do is write one test for the main method, just have a big list of values or something like that, and then test the actual output. So we don't actually have a test for our main method.
Can you run this?
Run the tests?
Yeah.
Yeah. It's not super fun. But is that picking up? Yeah. So all tests passed. Yeah. So, like, I don't know, it took us a little bit because we haven't been doing it. It's like, oh, how do you call those methods from over here? Do we have to instantiate the object? Or should we make it static? And, kind of stuff. But it's good.
Okay. Any questions for these guys? Oh, yeah, thanks. Anybody else want to present their work? No? So, do you guys want to come up? Okay. Let's see, which are you guys on Google Plus here?
Yep.
Is you?
Yep.
Okay.
So, yeah, we took a similar approach to the other guys, where we just check divisibility for both 3 and 5 at the same time, and return fizz buzz if that's the case. Otherwise, yeah, you do everything else. But we did it all just in the main. We just call that function 100 times. That way, we could easily set up the unit tests, where we can just do a simple assert true for each test. Group them in 10, so I test 1 through 10 there, and down here I test 11 through 20.
What was that?
They type fast.
I'm guessing it's cut and paste.
Yeah, oh yeah, copy paste for this part.
Well, actually, that's a good point. Okay, so there's a lot of copy paste here. Is there an opportunity for refactoring? So they did the red and the green. Is there an opportunity for refactoring here?
expected and passing the value to it.
Like the expected and equals value, expected and the actual value, or yeah, expected and the actual value. Yep.
How would you do that? Also, you could do assert equals, and then you'll go to those, and you can have to do the dot equals.
And pluses minuses. Why would you want to do assert equals versus assert true?
Less code.
Maybe a little bit. Not calling the equals.
Less method calls, less code.
Yeah.
If it fails, it's easier to see.
I think for me, it's the when you do an assert equals, the failure, the error message tells you, oh hey, I expected one with the string one, but I got fizz, as opposed to what's going to happen when assert true fails. Expected true but got false. It doesn't give you a lot of information, so I think that's a case where assert equals would probably pay off a little bit more. That's good. Yeah.
Kind of question. So it seems like I've kind of wondered this in different ways throughout the program, but like this is like calling a method to make it easier to test it. Like, could you test the output if you're just doing like print lines from main or something instead of returning this kind of thing? Or?
You could, and that's what the invoke main test case, the thing that we saw like in the student did for you.
Yeah.
And it's interesting that to me is feeling more like an integration test than it is a unit test, because there's like this I/O happening. You have to capture and everything. And yeah, I suppose it's all sort of wrapped up in the invoke main test and that main method result object and stuff like that, the MMR. I think that the approach that they took here is a good one, where it's like put all the logic in a method that can be tested, the static get fizz buzz, and then just call it a bunch of times, right? You can go back to your main app or your main class, right? Because look how simple the main is. Hey, what's going to go wrong? It's less likely that code is going to go wrong, and something's going to go wrong in that code. So you can write easy tests to test all the real logic, which is there, and get fizz buzz, and then you sort of by inspection you run your main, and it seems to be doing the right thing. That you can test that manually.
Is there? I know that after taking 201, they talk about overhead incurred from method calls. Like you sort of get this impression of, I don't want to have a lot of method calls because I'm going to get, I'm going to overflow. But like
because it's 1984,
right?
Yeah.
Yeah,
Seriously.
You can see it. It's not IA32. It's like orbit, but
yeah.
So in reality, though, there's no. It's not bad to do method calls when you don't need to.
No, and that's the thing. There's the method code that appears in the source, but at runtime, this is something we haven't really talked about that much. The JVM has something called the JustInTime compiler.
Right. Yeah.
And so the whole idea is that it's translating bytecodes into machine code, and it's not like it's not just translating it; it's optimizing it. It's taking the code and it's like, wow, look, you've invoked this method 200,000 times. I'm going to try really, really hard to make it super, super fast. And it does things like method inlining, or it's like, okay, well, instead of like the overhead of having to, pop a new frame onto the stack and then jump to a new address, they'll just inline all of that, all of that code, and they can look at, it can do all sorts of optimizations and across method calls essentially. And so, even though there might be a method call in your source code, at runtime there might not be a method call, right? So, the micro benchmarking can be dangerous, and there's a very fine art to it. And it's something that I gotta admit, it's even kind of beyond me. Where it's like I prefer to look at macro benchmarks. Okay, well, let's run. Let's scale the amount of data that's piping through that's being piped through the application. Okay, let's run it for a long, long time and see what happens. While of course there is still call for highly performant code, most applications ought to be optimized for a pleasant user experience. Ought to be optimized for getting the job done what needs to be done. And because if your application doesn't solve the problem or solves it in a way that the user ends up taking, ends up spending 1 minute, which should take him 5 seconds, who cares if when you press go, it's really fast, right? So anyway, that's sort of my thoughts on that. Awesome. Anything else for these guys? No? Yeah, thank you very much. Okay. Anybody else want to? I'll bring you guys in the back.
We got one.
Yeah, come on.
We tried to do testing, but we.
No, let's come up and talk and see. See here, is this you guys?
We tried taking different.
Oh, no, it's, we're looking at here. Okay.
We're not. I couldn't get it.
Oh, no, wait. Oh, you're not on the plus?
I tried Hangouts, but it's. I don't need to sign in. So it's.
That's weird. Try reading that page there. Oh, let's try to stop it. Oh, wait.
Just had a question.
Join. Thinking about it. Right. Oh, there.
Oh yeah.
Okay, you want to screen? Oh, you need to share your screen in the Hangout.
Which one?
It's over on the left. Screen share.
There it is.
Yeah. Right.
Maybe choose.
Okay.
All right.
Okay, so got some more code up here. So tell us about your experiences, Sean. Hey guys, can we...
So this might be more calls and more operations than needed, but we implemented this string builder so that we didn't have to check multiple times for mod 5 or mod 3. And so it'll just build a string every time it has to build a new string, but it will append fizz and buzz if they're both mod 5 or mod 3 kind of thing. So a little bit different.
Cool. What do you guys think? Pluses, minuses?
So the output's just going to be one string?
No. It'll output the correct way.
Oh, yeah.
Like every time you have to basically delete that old string and create a new string builder with just an empty string, and then it'll check that it's empty.
And speaking.
So it's definitely not efficient in any way. It does. Correct. See, I don't know how inefficient that is as compared to always checking an extra one, maybe. But
How would you find out? So let's say you were asked, okay, hey, compare the efficiency of the various implementations that you've seen tonight. How would you do that?
You have to run it a lot more.
Okay, yeah, it's like what timing test would you perform?
Just how long the application runs with two versions, one with string and one with string builder.
Yeah, just comparing them, yeah. I think if I were to do it, I'd pump a lot more data through it. Because, we're running these things and, one of the things about the JVM is that it takes a while to start, it takes a little while to warm up, too, to, do all the just-in-time compilation. So I'm guessing that, since these guys are, since all of the programs, it's kind of small and trivial that, it doesn't have a chance to sort of get its juices flowing. So, yeah, I'm going to pump a lot more data through that.
What would be that, roughly, obviously? You do 1,000, that's still probably going to go big. 10,000.
For this algorithm, we're talking like millions before it, and really it's going to be spending all this time doing output anyway, or I/O probably, right? And so then in terms of, and this is important stuff to know, right? When you're constructing your constructing performance tests, that oh gee whiz, for all of these, the most expensive operation. Well, what's the most expensive operation? Writing to the console, right? Doing the writing out to standard out, and everybody does the same thing there. So it's like, in reality, is there much differentiation between the algorithms? No, because you are I/O bound. Because the expensive thing is performing I/O. And so maybe like it would be faster to build up the entire string of memory and then write it all out in one fell swoop. Maybe that's faster than just writing out each time and doing the flush. Maybe, right? And so that's, so if I were to try to super optimize this, maybe that's an approach I would take. But measure to see if it really helps or not.
So can you generalize that to say that timing tests would usually be testing things like sending stuff over sockets and stuff like that, rather than testing just like Java regular language operations?
Well, I mean, it all depends on what you can optimize, right? If you are network bound, okay, what you have to optimize is your network speed, okay, and that means changing hardware, right? Stuff like that. But if you can demonstrate that you're CPU bound, or that you are not, so you've got a multi-core system and you're not using all your cores, right? So like one CPU is pegged because you've got a single thread application. Okay, maybe you need to figure out how to make it multi-threaded. Performance is an art, and it's it's either art or it's black magic, depending on how you look at it, because things are very finicky, especially and so like because the hardware has gotten so much more complex, and because now we're programming abstractions further and further away from the hardware, it makes it really difficult then to be able to reason beforehand, or actually reason even as you're running it, in terms of what's going on. And so then the sort of the dream that all you need to do is look at your code and find the places. Yes, there are times where you can have this like horribly inefficient stuff, and there are good profiles for Java to help you find this. Oh, I'm doing something dumb here. You probably weren't realizing it because it was like this thing interacted with this thing, and all of a sudden you've got some one object, one thread is blocking another thread or something, and things are slower than you do. But anyway, yeah. Okay. Anything else for these guys? Okay. Thank you. Okay, I think that's everybody, right? Well, thank you. Hey, I really appreciate you guys participating in this. I'm going to close out I'm going to hang up the doodles. Okay, well, I hope that recorded okay. We'll find out, I guess. Yeah. Okay, and, I think that's all I've really got for tonight. So, actually, I want to do a quick retrospective. How did that work for you guys? Was that okay? Seem to enjoy it? Okay. Okay. Well, I'll be thinking about what we can do for next week. I like this. You guys seem to learn a lot, and it was good that you were, learning with each other instead of just listening to me spew.
I think it's better that we do something. After some point of time, we start phasing out if we are just listening.
Well, exactly, and really that's like I had this realize. Well, it's something that's been the last couple of times that sort of it hasn't felt right. And I was at the Agile Open Northwest conference over the last winter or whatever, and there was an open space session talking about Agile in education, and really what I got out of that was the approach that I'm taking, or I was taking with this class, wasn't as effective as it could be. And it's like, why, is it the best use of my time? Is it the best use of your time? Is it the best use of my knowledge to be up here, blah, 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 and you're sitting, no, it's really not. So I'll blah, blah, blah at home, and it's up there on the web, and honestly, it's up to you guys to figure out if that's how, if you want to invest the time understanding that. I recommend that you do, but you don't. Here in class, I wanted something more interactive. I wanted something where it's just not, where I'm facilitating your learning by answering your questions, by having more dynamic exchange, and really so that I can better serve you, because that's where I really see myself as someone who is, what is it, not the sage on the stage, but the guide on the side. I'm here to facilitate your learning. I can't pump it into your brain, right? I tried that for 10 years, it didn't work. I can't just pump it in there. Instead, I want to make sure that I can help you guys learn the way that you want to learn. That's why we're sort of mixing things up in terms of how we're approaching this. Anyway, any questions before we adjourn for tonight? Yep.
In the professional world, like how many hours a day would people be pair programmed? Would it be all hours or part of the day? Or?
Well, I can't say there's a hard and fast rule. It's really whatever works. And I've seen that, just like any new technique, like test-driven development or a new programming language or whatever, trying to go in whole hog, it's this culture shock. It's like, I've never worked like this before, or it's like, so unless you're used to pair programming all day, it's not like you do it all day. It's like, okay, we'll try it for an hour. We'll try it for a morning. And you might, pair with different people during the day. So I think... some of the models I've seen working, there's a transitional period, and then the team figures out what's the right amount of pair programming for them. Okay, well, nothing else. Thank you very much for participating in this experiment with me. We'll continue our experiment next week.